In this video, we're going to look at transforming a Riemann sum to a definite integral. The limit n goes to infinity, summation I goes from 1 to n, 1 over 4 plus I over n squared times 2 over n represents an integral. Integral a to b f of x dx. Let's find this integral. We start by looking at the definition of the Riemann sum. Limit n goes to infinity, I goes from 1 to n, f of xi times b minus a over n. This is a right-hand Riemann sum with equal partitions delta x. This is delta x here. And this is equal to definite integral a to b f of x dx. Let's find xi, the x values, the lower limit a, the upper limit b, the function f of xi, and delta x, which is a common width. So we're given limit n goes to infinity, I goes from 1 to n, 1 over 4 plus I over n squared times 2 over n. We start by letting xi be I over n. These are the x values. So if we plug in I equals 1, we get x1. That's 1 over n. If you put I equals 2, that gives us x2. Is 2 over n. I equals 3, that gives us x3. That's 3 over n. And I equals n, that gives us xn, the last x value, which is really b. N over n equals 1, that's equal to b. Now, how do we find delta x? The easiest way is to basically subtract two consecutive x values, x2 minus x1, for example. That's going to be 2 over n minus 1 over n. That's equal to 1 over n. More generally, delta x is equal to xi minus the previous x value, xi minus 1, that is I over n, minus I minus 1 over n, and adding or subtracting these two fractions, that comes out to 1 over n, that is delta x. So what we have is delta x is equal to b minus a over n, that's equal to 1 over n. Now, if we equate the numerators, b minus a is equal to 1, equate these two, clearly we can see that b minus a is equal to 1. That implies that a is equal to 0, since b was found earlier to be 1, since b is 1. Now we have xi is I over n. Let's build up the function f of xi. That's going to be 1 over 4 plus I over n all squared. Let's rewrite this as 1 over 4 plus xi squared. We now have all the pieces of the puzzle. We have a, the lower limit, to be 0. b was found to be 1. f of xi, the functional values, is 1 over 4 plus xi squared. And that implies that the function f of x that we're going to use for a definite integral is 1 over 4 plus x squared. Now let's factor out 2 from the Riemann sum. So we have limit n goes to infinity, I goes from 1 to n, 1 over 4 plus I over n all squared times 2 over n. If we factor out the 2, we get 2 times limit n goes to infinity, I goes from 1 to n, 1 over 4 plus I over n squared times 1 over n. It's clear that this part is f of xi. That's the functional values. This part is a real delta x, and that's the reason for factoring out the 2 and putting it into the front. Alright, so we have 2 limit n goes to infinity, summation I goes from 1 to n, 1 over 4 plus I over n all squared times 1 over n. This is equal to 2 times the definite integral 0 to 1 f of x, which is 1 over 4 plus x squared dx. So this part here is f of xi. 1 over n is delta x. In a definite integral, this part, 1 over 4 plus x squared, is f of x times dx. This is just dx. So let's summarize what we've done. To summarize, we were given limit n goes to infinity, I goes from 1 to n, 1 over 4 plus I over n all squared times 2 over n. We factor the 2 out, we get 2 limit n goes to infinity, summation I goes from 1 to n, 1 over 4 plus I over n all squared times 1 over n. This part is a function, that's f of xi, that is 1 over 4 plus I over n squared. This part is delta x. We transform that into a definite integral, and we get 2 times the lower limit 0, the upper limit 1, 1 over 4 plus x squared, that's the function, and integrated with respect to x. This is a definite integral. Riemann sum, so this was a Riemann sum, was transformed into this definite integral. All right, thanks.